Okay, hello, welcome to the second video on question 2 of the June 2011 M1 paper as part of the revision series. This one's about momentum. There is a particle with a mass of 3 kilos and one with a mass of 2 kilos. They're moving in opposite directions on a horizontal plane when they collide directly. Immediately before the collision, P has a speed of 3 meters per second and Q has a speed of 2 meters per second. So that's P and Q. As you read this, always make sure you're drawing it as you're reading it, so you interpret it correctly. Okay, this guy's going in that way, this guy's going that way. This is called P, that's Q. This has a speed of 3 meters per second, and the other one has a speed of 2 meters per second. Okay. They collide directly. Immediately before the collision, this one has 3, that one has 2. Immediately after the collision, both particles move in the same direction. This has 3 kilos and that has 2 kilos. That's really important to write down. So mass of P equals 3 kilos. Mass of Q equals 2 kilos. So P is heavier than Q, and more massive than Q, and not only is it more massive, it's also going quicker. So they both move together in the same direction. It's going to be towards the right. Hopefully you can see that they're both going to go together towards the right. They're going to have a combined mass of 5 kilos. And let's see what they ask. The difference in their speeds. Oh, I see. No, I interpreted this wrong. They both move in the same direction, and they have a difference in their speed of 1 meters per second. So I thought they were combining. Okay, that makes more sense. So let me delete this and apologize for the mistake. At least that way you can see I'm not I'm doing it on the run, not tricking you. Immediately after the collision, both particles move in the same direction, and the difference in their speeds is 1 meter per second. Okay, so hopefully you can see that they're both moving in this direction. So here would be Q, right? Because it's not going to go through it. This one's going to be Q, and this one's going to be P. Okay, so this I'm going to call VQ, and this I'm going to call I go back, VP. Okay, and we have some information relative to them that their difference is going to be 1 meter per second. What's important to realize is that since they don't go through each other, this guy is going to go faster. So VQ is going to have a velocity of 1 meter per second faster than VP. Okay, so hopefully you can see that they're not going to go through each other. Then VQ is going to be 1 meter per second faster. So VP plus 1 is going to have to equal VQ. Okay, so we know that relationship. And so let's write down the law of conservation of momentum, which is what's going to allow us to solve this. The question itself is to find the speed of each particle after the collision. Okay, so the speed, and this is a big part of the question, then there's a 3 mark 1 for the impulse. Find the speed of each particle after. So let's find VP and VQ so that they satisfy the equation. So remember the signs and the symbols, and everything is really important in that sense. We normally take in projectiles up to be positive and down to be negative, and in momentum questions we tend to take right to be positive. Okay, so I'm going to write this here so the examiner knows that I'm taking that to be positive, and my equation for conservation of momentum should be the momentum before equals momentum after. Total momentum before equals total momentum after. How much momentum do we have at the beginning? Well, a combination of plus momentum and negative momentum. Here we have 3 times 3 from particle P, right? We have 3 times 3 from that particle, plus, I'm going to write it as plus even though the negative velocity is going to now indicate a minus 2 here, and a mass of 2. So momentum before, you can write it here if you want, momentum before equals 9 minus 4, right? So that's 5 kilogram meters per second, mass times velocity, kilogram meters per second, for the momentum before. And the algebraic form of the momentum after, since they're both going in the same direction, is going to have to be mass of p times the velocity of p plus the mass of q times the velocity of q, right? And that's going to have to be equal to the momentum that we had before, so that's also going to be 5 kilograms per meters per second. That's going to be momentum after. Okay, now what's interesting here is that we have a formula here for the velocity of one in terms of the velocity of the other, meaning that we can just sub this into here, for example, and then we have the whole formula in terms of only one variable that we don't know, and everything else we know. We know mp, we know mq, we know 5 here, and so we only have one letter that we don't know. So let's rewrite that. mp times vp. Actually, I'm just going to put the numbers now. mp is 3, so I'm just going to put 3 vp plus 2 for the mq times vq, and vq is just vp plus 1 equals to 5. So let's open this up and do some algebra. What do we have? 3 vp plus 2 vp plus 2 equals 5. So 3 equals 3 plus 2, that's 5 vp. Well, I pass the 2 to the other side, and vp is therefore going to be 3 divided by 5 meters per second. Okay, you can put that in the calculator if you want, and 3 over 5 is 0.6. Positive, right? That makes sense because it's going to the right. Now if we want to find out what VQ is, then we just enter that into the equation. VQ is equal to VP plus 1, and if VP is 0.6, VQ should be 1.6 meters per second, and they give you very generously 5 marks for that. Hopefully that process makes sense. And if you want to check the mark scheme, 0.6 and 1.6, so that satisfies everything. Let's go and have a look at, I don't know why I keep getting this thing here, it's very annoying. So let's go and have a look at the second one. Find the magnitude of the impulse exerted by Q on P. Okay, so on P by Q. So the question here is then, let's draw the what's going on again. This is part B. Question 2, part B. Running out of space, and we had the ball going like this with 3 meters per second and a mass of 3 kilos, and that was P. And then we had Q that was going in that direction with a mass of 2 kilos and a speed of 2 meters per second. And they're asking us to compute the change of the impulse which on P by Q. So the guy we're concentrating on here, it's important to highlight it, is the on P by Q. So we want to know the impulse on P. Now the impulse on P, impulse is just change of momentum. Okay, change of momentum is the impulse. It can be positive or negative, right? If I'm going in this direction and my momentum increases because I get a collision of some sort behind me, and my impulse increases in that direction to the right, then my change of momentum is positive because it's changing my momentum towards the right. Similarly, if I'm going in this direction and suddenly I bash into something and then it gets me going in the opposite direction, or it even slows me down, which means that the change in momentum has also been towards the right, then the change in momentum is also positive. Any change in momentum towards the right is going to be positive, whether it's slowing me down or it's speeding me up in the same direction. Okay, the opposite is true for negative momentum. Anything that increases my momentum in that sense is going to be negative momentum, and anything that decreases my momentum in this one, which means that it's actually changing it to the left, will also be a negative change in momentum. Okay, hopefully that makes sense. Change in momentum can be accelerations in the positive sense that they speed you up, or they can be decelerations, and they can both be a positive change in momentum if they're both towards the right. So what's happening to P by Q here? It's going that way, and it's going at 3 meters per second, and later it goes at 0.6, so it's actually slowed down. So what direction was the change in momentum? Towards the left. So therefore the change in momentum that I need to calculate needs to be, if I do things correctly, negative. Okay, it's really useful to be able to tell all of that before you start the question. So if we started now straight away, we just want to know the momentum, the change in momentum of P would have to be the momentum of P after minus the momentum of P before, right? I don't know if you can see this color very clearly. I'm going to change to a brighter color. So change in momentum, which is impulse, right, equals, I'm not going to write it like that because that looks strange, but hopefully you can see that this is impulse. Okay, from here the examiner already knows what you're talking about. So momentum after is 0.6 times its mass. Its mass is 3, so the momentum after is just 3 times 0.6. Momentum before was 3 times 3, which is just 9. So you can see hopefully that this is bigger than that, so we're going to get a negative change in momentum, which makes sense, and we get 3 times 0.6, which should be 1.8, minus 9, that is minus 7.2. You can call impulse in Newton seconds or just kilogram meters per second. Again, this amount of meters per second is change in momentum. So the impulse is then minus 7.2. Okay, we go and check on the mark scheme, and we get 7.2 Newton seconds. Okay, they're both allowed. Newton seconds are the same thing. Okay, that is because force is actually change in momentum divided by time, or impulse divided by time. So change in momentum is force times time. Force is newtons, time is seconds, so that's why you can express impulse in Newton seconds. It's an equivalent unit, and you won't lose any marks for that. Okay, so that was question 2, and I'll do question 3 in the next video. See you then.